the column. Okay, so the column is non-polar in nature and the solvent will be polar in nature. Okay, the non-polar component which will be highly interacted with the column and that elute slowly. Okay, at the last it will be eluted. Okay, whereas the polar compound will be eluted faster. Okay, so based on the retention time we can identify the compound. For example, if I have a standard, okay, I am running the standard initially and how much time which is required from the injection to the elution. For example, if I have a for example, there are different types of dictators are there, and if it's a sugar molecule, if it's a glucose, okay, if it's a glucose, then the glucose standard will be injecting. Okay, so the what's the time or what's the retention time for the glucose will be initially calculated, and when we have a mixture of compound and we want to find whether the glucose is present in it or not. Okay, so we will be getting a graph and different peaks. Okay, so once a particular compound is detected and like that show us like graph just to give the for example, we will be getting the graph like this. Okay, for example, this is acetone and this is acetaldehyde. Okay, these two compound, and for example, acetone we will be getting a peak and acetaldehyde also will be getting a peak. Okay, so what's the time required to like time in minutes? It's nearly 3.5 or 3.8, that range. Okay, so whichever compound which is giving a peak or the compound which give a peak at 3.5, then we can easily assure that that is acetone. Okay, with the standard, first we will run the standard and we will be standardizing it. Okay, so the standard peak we got at 4 minutes. Okay, so whichever peak we are getting at 4 minutes, which is nothing but the particular compound, that's the standard. Okay, we don't need to look after for other compound. So whichever peak we are getting, that peak corresponding to the particular compound, that's the standard. Okay, so because we don't have mass spectroscopy detector, based on the time of flight we will be identifying the compound, that is not available. So we have the 3 types of detectors are there. You got the concept, right? So how we are detecting? There is a mobile phase and a stationary phase is there. If the mobile phase is polar and stationary phase is non-polar, then it is known as reverse phase chromatography. If the mobile phase is non-polar and stationary phase is polar, then it is normal phase chromatography. Okay, and here we will be having a reverse phase column, like that is nothing but C18 column, and there are different types of detectors are there. So the first one is refractive index detectors. It's mainly used for the sugars. Okay, sugars. There is a multi-fluorescence detectors are there, which is commonly used for hormones, then vitamins and all. Okay, and the third one is photodiode array detectors. Okay, it can be used for detection of different compound or multiple compound at a time. Photodiode array detectors. So first initially we have to standardize, then we have to detect the we can detect the compound. Okay, PDA detector is also known as PDA detectors. So at a time we can check the elution rate for different compounds and we can identify the concentration. Okay, so as you can see here in this graph, so this is the in which point we are getting the peak, that is the retention time. Okay, from the initial to that time, the particular peak. Okay, the center of the peak we are connecting with the point, that's the retention time, and the area under the particular peak, that is giving the concentration of the particular substance. If the long area, then is high concentration is the, if it is short area, then lower concentration, present in the lower concentration. Sometimes like when this dragging and all happens due to the interaction, sometimes the compound which is interacted with the column, so this backlashing and forward lashing happens. It's mainly due to improper cleaning of the column and some other compound which adhere to the surface of the column, and that may lead to the backlashing of the material. Okay, so here there is an injector is there. Okay, so as I will be showing the injector, we have 25 microliter injector. This look like a syringe. Okay, this look like a syringe and it's 25 microliter injector. Okay, so this injector we are commonly used here, and we can calculate like even here, even if you want to inject 5 ml, 10 ml, 15, 20 and 25 ml, and it's very minute syringe. This needle, like the hole is very small. Okay, that's why it is micro syringe. Okay. So while doing this experiment, we have to be too careful because each and every component is highly expensive. And here this is injector, we can inject here, and we can, after keeping this syringe, we can inject, and this system has to be inject that particular solution. No, so we will be putting it on and load the sample. Okay, so actually the software is there is some cracking happened with the software, something cracked. Okay, so that's why we are not running the system for last 2 weeks. And there is a pump will be there, and the pump will be pumping the particular sample into the, here we will be keeping our column. Okay, so it will be pumping to the column, and we can decide which detectors can be used. Okay, so either the PDA detector or refractive index detector or the multi-fluorescent detectors. Okay, so the pump will be pumping the sample into the column, and from the column it will be eluting slowly different components. Okay, and we will be detecting the sample with the different detector. That's the basic principle. Okay, if it is running, I can show it like how it is working, happening, and we can get the eluted sample at the back side after detecting. And the refractive index, even all the detectors are non-destructive detectors here. If the, in case of the flame ionization detector, you might have seen, this is destructive detectors, but this is non-destructive detectors. Okay, so because it is passing through refractive index, like the principle behind the refractive index, right? Refractometer we are using for detection of the TSS of the material. So if it is sugar, definitely they will be having a specific refractive index for the different compound. Based on that, whenever it is diffracted in the plane polarized light, we will be getting a, like spectroscopy, we will be getting a angle. Based on the angle, we will be detecting the particular compound. That's the principle behind it. Fluorescence in the sense, whenever a particle or a material which absorb light and it will emit light after sometimes. So which type of light is emitting and what's the wavelength of the light, that will determine the particular compound. Okay, for example, whenever we are doing spectroscopy, like UV visible spectroscopy, there are different absorption region. Same way here also, the absorption which is belongs to the fluorescent spectrum. Okay, fluorescent region, then we can identify the particular compound. Okay, and here the photodiode array or PDA detectors are there. Okay, so even it's a multi-phase detector, like when at a time we can identify different compounds. Okay, like even absorbance at different region can be detected at a single time. For example, if a mixture of compound having different substance, like different compounds are there in a particular solution as a mixture. Okay, so each and every compound having different absorbance, so at a time we can detect all the absorbance. Okay, that's it regarding the PDA detectors. That's are the basic principle behind it, and there is no much complication. If we can with the software, it can be easily done. Like whenever we are injecting sample, we will be getting, depends upon the detector, we will be getting the concentration of the particular substance. Okay, and the area under the graph will give the reading. Okay, so that's all. If you have any doubt regarding this, sample preparation procedure in the sense, for example, we have to require highly pure sample to be injected. Okay, so for that we will be using deionized water. Okay, first of all, the first thing is deionized water is required, and the concentration should be standardized. Okay, so for example, if our standard having 50 mg per ml, so it should be in the near range. If 50 mg per ml is our standard, then our sample also should be near range. Like if it is 50, then we have to in the, like even 5 to 100. If it is beyond 1000, then it is very difficult to identify, very difficult to get the calculation, because the graph will be too bigger and very difficult to calculate, and the accuracy will be matters. Okay, so accordingly we have to dilute the sample. First we have to dilute if for example, if I have a apple juice, okay, I have to filter the apple juice with, there is a different types of filters are there, and we already having a filter. This will prevent the entry of larger particles inside the column. Okay, so even though we will be filtered with the Wattmann's filter paper, the sample should be mixed properly, and Wattmann filter paper will be filtering and will be diluting the sample. even 1:10 or 1:100 ratio, depends upon our requirements. Okay, if it's containing high amount of vitamin, we know like what will be the range, but exactly don't know. Okay, so we will be in case of mass spectroscopy, that is not a matter, but in case of normal HPLC with the detector system, it will be very difficult. Okay, so we will be diluting according to our requirements, and after that we will be preparing this, we will be adding the solvent into it. Okay, adding the solvent, we will be using different solvent, and even most probably we will be adding deionized water as a polar solvent. Water is fine, why we have to go for other polar solvent, or acetone we can use, depends upon the solvent we can add, and we can prepare the sample, and we can again there is a micro syringe is there. With the micro syringe we will be taking it out, because there is also a filter thing is there. Even any particle from our hand or anything, if it is entering into the system, that will affect that will completely destroy the column. Okay, so we have to be careful while preparing the sample. After filtering, we will be injecting it again in the beside the injector there is a filter disc will be there. With that disc only we will be injecting and taking the sample with the injector, and we will be introducing into the column. Okay, so any other doubt?
Can we use a mixture of solvent or only single solvent?
Mixture of solvent in the sense, like for example, depends upon the polarity. You are talking about the mobile phase, right?
Yes.
Okay, we can use mixture of solvent or single solvent itself. So for example, there is a standard procedure given for every sample. For example, vitamins, different vitamins having different polarity. Okay, accordingly we will be using different types of mixtures. Like for example, they will be asking for acetone and hexanol, or methanol or ethanol mixture in 1:2 ratio, or 50:25 ratio, like that. Different ratio they will be giving. Okay, so they will be giving the ratio according to the solvent. So there is a standard AOAC, AOAC procedures are there. Okay, so according to the procedure we will be making the sample and the standards. Okay.